Alright, in this video I'm going to go over the basics involving direct and inverse variation. So there's a lot to get to, so I might move a little bit fast, so if you need me to pause, do whatever, do that in the video and replay it. So the first one I'm going to talk about is direct variation. The way that kind of works is we're going to be talking about mostly two variables like x and y. And the way directed variation works is if x is increasing, what's going to happen is y increases. So if one goes up, the other one increases. The other way it works is, what if x is coming down? If x is coming down, then y is coming down. So they both go and work directly with each other. If one goes up, the other one goes up. The one goes down, the other one goes down. The formula for this is we're going to have y equals a times x, where a in this case is our constant of variation, and that's going to be very important with a lot of the problems. A is our constant of variation. So this is the formula, and this constant is super important, and when I'll get to it later, it's going to be very important to know, well, I have this equation, let's solve it for x. So this is the direct variation equation, y equals a times x. But I'm going to solve this for my constant, meaning I want to get my constant all alone when dealing with direct variation. So if I want to get a all alone, well, right now I'm being multiplied by this x, so I divide by x, divide by x. So my constant of variation when dealing with direct variation is, since my x is over here, divide out, a equals y divided by x. Now, right now this seems kind of, unimportant. It will in a little bit. So y equals a times x, that is my direct variation formula. That is how I find the constant. So I just solve this for a to get my constant of variation when dealing with direct. The other type of variation we're going to talk about is inverse. And the way that works is if one of my variables x is going up, we'll say, if one goes up, the other one's going to come down. So as one variable gets bigger, the other one is going to get smaller. It works the opposite way too. So say I start making x smaller and smaller numbers, then y is going to get bigger and bigger and bigger. So they go opposite directions. That is inverse variation. The formula for inverse variation is we're still going to have y equals, so that's kind of a common theme there, still have my a, my constant of variation, which again is going to be important, divided by x though this time. So the difference is instead of multiplying by x, we're going to divide by x. Notice how a would be on top both times. That is my equation, or formula if you want to call it that, for the inverse variation problems. One thing I'm going to do before I move on to some of these other questions is let's solve for a. I want to get a all by itself because this is going to be important to us in about a minute. So I want to get a by itself. Right now a is being divided by x. So to get rid of a division by x, we're going to multiply both sides by x. When you do that, x's are gone here, so we get a equals x times y. What you'll notice is these almost seem like flip-flops of each other, but what I would do as a student is just remember y equals a times x for direct, y equals a divided by x for inverse. Solve each of those for a to find those constants. So just work on internalizing those two pieces. So my next set of questions here, we're going to determine if the equation or graph, I should say table, not graph. The equation or table is direct or inverse variation because I got some tables down there. So looking at this first one, we have y divided by 3 is equal to x. Now when working with these problems, notice that the equations and formulas I use for direct and inverse variation, y was by itself on both of them. So again, if it's direct, it's y equals a times x. And if it's inverse, y equals a divided by x. So direct and inverse. So I want to get y by itself on these before I even try and determine if it's direct or inverse. So on this one, I have y divided by 3 equals x. Notice I have a division by 3 with my x, or sorry, my y. I wanted to get y all alone, so I'm going to multiply both sides by 3. Now why that's important is if you're multiplying and dividing by 3, those are inverse operations, so we end up with y equals 3 times x. So now that I have y all alone, I could start looking and thinking, well, is this direct or inverse? And just by looking at it, direct, you're going to have your constant times x. Inverse, you're going to have your constant divided by x. I have a 3 times x, so this one is direct. So my next one, I have y equals 2 divided by x minus 3. So I already have y equals, so that's great. I have 2 divided by x, which looks awfully similar to my inverse, but I got this minus 3 there. Notice how there's no addition or subtraction involved with either of these. So it's not direct because we're dividing by x. Inverse, it looks very, very close to it because we are divided by an x, but the problem is that minus 3. So actually this one is neither direct or inverse variation. And it's because of that minus 3. We can't have addition or subtraction there. We're only worried about multiplication and division when we're dealing with variation. So my last one, I have x times y is equal to 8. What I'm wanting to do is I would like to get y by itself again. So I have y times x. So if I want to get rid of the multiplication times x, I'm going to divide both sides by x. The reason this works out for us is multiplying and dividing by x are inverses, so I get y equals 8 divided by x. Now looking at this and comparing my original direct and inverse variation functions, I notice that this is in fact an inverse variation problem. So we have direct, neither, and inverse. So I had talked about those constants earlier. That's where these next problems are going to come in. So I have a table of values xy, table of values xy. To check whether it's direct or inverse, we can't exactly just try and figure out, well, which of the two formulas does it match? Does it match y equals a times x or y equals a divided by x? That's pretty tough to do. What we can do is think about a constant. Remember, a constant is something that always stays the same. No matter what, it always stays the same. So that's why I included these two pieces. So for direct variation, my constant should always be y divided by x. For inverse, my constant should always be x times y. So when I'm looking at constants, I'm going to look at, do these hold true? Because remember, a constant is something that is consistently the same, always the same. So what I'm going to do is I'm going to check the table first for a direct variation, which earlier we solved and said, well, if it's direct variation, then a should be y divided by x. So what I'm going to do is I'm going to go to each column here and figure out what y divided by x is. Now this is something you could easily do on a calculator. I'm not going to show a whole lot of it. So like this first one, if I'm going to do y divided by x, I'm going to take that 30 and divide it by 2.5. So for this first column, I got 12. Great. So now I'm going to move on to the second column. So I have a y of 48 and x of 4. So I'm going to do y divided by x again. 48 divided by 4. I got 12 again. And I continue that on. Y divided by x. 90 divided by 7.5. Got 12 again. And then 108 divided by 9. I got 12 for a fourth time. Remember that constant's consistently the same. I got 12, 12, 12, 12. Now remember, this a equals y divided by x was what we solved for the constant of direct variation. Since these are all the same, 12, 12, 12, I know this table represents a direct variation. So let's move on to the second one. I have x divided by y, table of values, or sorry, x and y, table of values. So the first thing I checked is I'm going to look for, well, do we have direct variation? Remember from earlier, a equals y divided by x. So I'm going to start going through the table. So I'm going to start with 35 divided by 12. And for that first set, I get, we'll call it 2.9. Then I'm going to do 84 divided by 5. My second value there, I got 16.8. That is an issue. These numbers already don't match. And remember, my constant needs to be the same all the way throughout. So my y divided by x, the numbers are not constant. So I can already stop and rule out direct variation. Before I say this is inverse variation, let's check it. So when I solve for my constant a up here, I got a equals x times y. So down here, I'm going to check a equals x times y. And my constant should be the same throughout. So I'm going to start with my x and y there. I'm going to do 35 times 12. So I got 420. Try my next one. 84 times 5. 420. 168 times 2.5. 420. Do my x times y again. 1.5 times 280. 420 again. Notice how these are all the same, and my a equals x times y. My constant is the same throughout. A equals x times y related to my inverse variation formula there. So I know this table is inverse variation. And that was a video on the basics of direct and inverse variation.